Lay down, let your shoulders sink into the quiet space around you, and let your eyes grow soft. This story moves slowly, like a calm breath, and it will carry you without effort. Let the weight of the day settle far behind you as you listen. Subscribe to catch a new documentary every night and drop a comment telling us where you're tuning in from. By the way, what time is it over there? Okay, just one last question before we get started. What first made people wonder what lies under the Pyramids of Giza? The question rises like a small echo in the dark stone, asking why the ground beneath these ancient monuments has drawn so much curiosity for so many years. It is not a question about myths or hidden worlds. It is a question about real stone, real earth, and the long work of science that studies what sits below one of the oldest and most studied places on Earth. The Giza Plateau is a wide, raised stretch of hard limestone. This stone formed millions of years ago when the land that is now Egypt lay under shallow seas. Layers of shells, sand, and tiny life settled and packed together until they became solid rock. Over time, the sea pulled back, the land lifted, and this stone stood high above the river plain. That high ground became the place where the pyramids were built. The ancient builders understood that the stone beneath their feet was strong enough to hold even the heaviest blocks without sinking. Even though the plateau looks dry and solid, it holds a complex shape below the surface. Natural cracks run through it because of how the rock dried and shifted over time. These cracks are not signs of human activity. They are part of the geology itself. When rain fell in rare bursts over thousands of years, the water slipped into these cracks and slowly widened a few of them, carving small pockets or channels. These are known as natural cavities. They form in many places around the world where limestone sits close to the surface. When early explorers first walked across the plateau in the 19th century, they noticed some of these openings. Some seemed like dark holes cut into the rock. Others were thin slots that led down into tight spaces. Because tools were simple back then, many explorers relied on sight alone. They often wrote brief notes about strange hollows or downward cuts in the stone, but they did not always understand what they were seeing. Later readers sometimes took these notes and stretched them into ideas of deep rooms or wide networks. In truth, most of these early observations were of natural features or small cuts created by ancient workers who harvested stone from the site. The plateau served as a quarry in the time of the pharaohs. Workers chipped out large blocks for temples, pyramid casing, and nearby structures. Quarrying left behind smooth faces, corners, and leftover cuts in the rock. When these surface cuts met natural cracks, they created odd shapes, half natural, half human-made. This mix of forms explains why the first maps of the area showed confusing openings and trenches that people in later centuries sometimes mistook for hidden paths. As more organized study began in the 20th century, archaeologists sent teams to examine these features with care. They entered some of the cavities, measured them, and found that most of them did not lead far. A number ended within a few meters. Others were too narrow for a person to enter. None of them formed anything like streets, clusters, or chambers that could be labeled a city. What they found matched what geologists expected: a natural rock body shaped by water, heat, and time. The plateau's hard upper layer sits above a softer layer of limestone. This lower layer has small pockets where fossils, softer stone, and early marine material rest. Over long periods, this layer lost moisture and sometimes broke apart in small collapses. These tiny collapses created depressions just beneath the upper surface. When workers built structures or moved stone above these points, they sometimes widened the surface cracks without knowing it. Many of the mysterious holes described in old writings came from such processes. Modern researchers use tools that let them study the land without digging. Ground-penetrating radar sends waves into the earth and measures how they bounce back. This helps reveal changes in density, like where a space or cavity might lie. On the Giza Plateau, radar readings show a surface with an uneven pattern of natural voids and ancient cuttings. None of the images show organized rooms or carved pathways. Instead, they show scattered pockets, each shaped by natural geology or simple rock removal. These pockets do not connect in meaningful lines. They do not form clusters. They do not show any sign of planned space. Seismic studies offer another view. Researchers create small vibrations on the surface and measure how the waves move through the ground. Dense stone carries the waves differently than loose stone or open space. These readings confirm the mixed nature of the plateau's subsurface. Firm rock in most places, soft patches in others, and the occasional small hollow. They do not show large hollow volumes that could support the idea of underground complexes. Every scientific approach points to the same conclusion. The structures beneath the pyramids are real, but they are few, small, and explained by the natural shape of the rock or by ancient quarry work. The Great Pyramid itself contains known internal passages. These were carved on purpose. The workers used copper tools, stone hammers, and wooden wedges to chip and pry the limestone. The descending passage leads down from the entrance toward a deep chamber carved straight into the bedrock. This chamber is often misunderstood by people who think it connects to deeper tunnels. Yet the chamber ends in plain stone. It is open and empty, with no side passages. It is not part of a larger system, and never was. Its rough walls show the marks of simple chiseling, not signs of extended use or hidden movement. Because the pyramid is built partly above the natural ground, its lower structure sits where the quarry layer once lay exposed. Workers carved the deep chamber to anchor part of the internal design. It was a construction choice, not the start of a wider plan. They left some unfinished sections, which some writers have mistaken for blocked passages. In fact, these areas were abandoned because the builders changed their design during construction. They do not lead to anything further. When modern scientists place sensors inside the pyramid, they measure how muons, tiny particles from cosmic rays, pass through the stone. These measurements can reveal empty spaces. The tests have shown only known cavities and a few small gaps, likely caused by construction methods. They have not shown the outline of large hidden rooms. They have not shown networks. They have not shown spaces under the pyramid that could resemble anything close to a city. Still, the belief that something vast lies below the surface has spread widely. This belief often comes from taking known facts out of context. People see that cavities exist and assume they must be connected. But not all openings in rock connect. Most do not. People hear that workers cut rooms into stone, and they assume there must be many more. But ancient builders had clear goals, and they did not carve where carving served no purpose. The science that studies Giza does not hide broad networks. It simply reports what the ground itself shows, and the ground shows isolated voids shaped by nature and by human labor. As scientists study the plateau layer by layer, they build detailed maps. These maps help explain why the pyramids have stood for so long. The bedrock is strong. The stress lines run deep. The few hollow spots do not threaten the foundations. Each map also makes the picture below clearer. The land beneath the pyramids is solid, steady, and mostly unchanged since the time of the pharaohs. It holds no great cities. It holds no long halls. It holds only the quiet forms of old stone and the traces of old work. This is the ground where our story now rests, the first piece of the larger view of what lies under the pyramids. From here, the path leads forward into more detail about how these features formed, how they were studied, and why the facts matter more than the myths that surround them. The story moves deeper now, staying calm and steady, as if the ground itself is guiding the pace. The light above the plateau fades from view, and the focus shifts to the long work of the ancient quarry workers who shaped the rock. Their actions change the surface and the layers just below it, leaving marks that scientists still study today. These marks help explain why some people later believed there were large spaces under the pyramids, even though the truth is much simpler. Long before the pyramids stood in full form, teams of workers cut blocks from the plateau. They worked in organized lines, breaking the stone in a slow, careful process. The rock was strong, but the workers knew how to use simple tools to open small cuts and widen them step by step. When they pulled out each block, they left behind a flat surface or a shallow trench. Over time, these marks spread across the plateau, forming long scars that ran in straight or curved lines. These early quarries were the source of much of the stone used in the massive structures above. As the work continued, some cuts reached natural cracks in the limestone. When this happened, the workers sometimes followed the line of the crack because it made the stone easier to remove. This choice did not come from a plan to make deep rooms. It came from the simple fact that broken stone is easier to lift. When they cleared these areas, the quarry floors exposed natural pockets in the ground. These pockets were small and uneven, but the workers did not go any deeper than needed. They took the stone above and around them and moved on. Years later, when explorers walked through these abandoned quarries, they saw these openings and wrote about them. Some wrote that they looked like entrances. Others wrote that the holes felt like the start of hidden rooms. Because the openings were old and covered in dust, it was hard to see where natural rock ended and human cuts began. This led people to guess at long passages that might connect somewhere deeper under the plateau. But modern teams have studied these same openings and found clear answers. Each one ends not far below the surface. None of them link together. Close to the Great Pyramid, more quarry marks lie under the surface layer of stone that once supported construction ramps. These ramps were used to move heavy blocks upward. When the ramps were later removed, they left behind shallow dips. In some cases, the upper surface broke away in thin slabs, revealing thin cracks beneath. These cracks were natural, but had been uncovered only because the ramps once sat above them. When early writers saw these exposed cracks, some believed people had carved them on purpose, but later studies showed that they were simply part of the stone layer itself. Some quarries sit near the Pyramid of Khafre. These areas show where workers removed large blocks for outer casing. The quarries cut into the hillside, creating terraced steps. In a few places, narrow gaps formed where soft stone fell away after removal. These gaps look like slender entry points, but only reach a short distance inside the slope. When explored, these spaces match natural patterns found in other limestone cliffs. They are shaped by water and time, not by human intention. Archaeologists studying these zones found chips of tools, dust layers, and traces of lime powder left by the workers. These finds tell a clear story. The workers were focused on removing stone, not building structures beneath. Even in areas where the terrain dipped lower, the patterns show extraction, not expansion. Marks on the walls show the direction of chiseling. The floor debris shows where the stone was lifted. There are no signs of chambers or corridors shaped for use. Everything matches the steady work of quarrying. When scientists record these quarries, they measure their width, depth, and shape. The shapes vary by the type of stone and the needs of the builders. Some quarries form long open pits. Others form square cuts. A few form irregular pockets where natural cracks guided the work. The variations are normal, and they occur in quarries around the world. There is nothing in their form that suggests hidden underground sites or planned interior spaces. Still, misunderstandings grew over the years. Some early drawings showed these quarries without full detail. A sketch with dark shading near a pit looked like a deep space. A quick line drawn to show a crack looked like a tunnel. When these sketches were shared in books, readers who had never seen the area imagined something more complex. Later, writers repeated these ideas and added interpretations that went far beyond the evidence. They spoke of networks and rooms, even though no such maps or findings supported these claims. Further confusion came from collapsed quarry floors. In certain places, the upper layers of stones settled slightly after blocks were removed. This created shallow holes with uneven edges. If a person looked down into these holes without proper lighting, the bottom looked like a continuation into darkness. In truth, the holes were only a few feet deep. But to those who already believed in hidden areas, these holes seemed like entrances. It took many careful studies over several decades to correct these first guesses. Another layer of misunderstanding came from the idea that the pyramids must have required massive underground support rooms or supply areas. People assumed that because the structures above were so large, the ground below must hold storage spaces or work chambers. But the workers used open-air work sites. They shaped most of the blocks in the sunlight. They stored tools on the surface. They did not dig large spaces under the ground for tasks that could be done more easily in open areas. Some quarries near the Sphinx add to this picture. Workers removed stone from the nearby slopes to carve the massive statue and to supply blocks for nearby temples. In doing so, they created deep cuts that reveal the lower layers of the plateau. These cuts sometimes exposed soft pockets where ancient shells had decayed. These pockets crumble easily, leaving small hollow spots. These hollows form shapes that look unnatural at first, but they follow the same patterns found in limestone cliffs, far from any human work. When mapped carefully, these pockets show no sign of design, direction, or purpose. Modern researchers have also looked for tool marks that might show deliberate underground construction. The marks found near the pyramid bases all point outward from extraction points, not inward as they would if people were carving deep rooms. The pattern is clear when viewed up close. Workers chipped the rock face to separate blocks. They did not dig long corridors. Each tool line, each break in the stone, points to work done at the surface. As scientists record these findings, They compare them with old claims of underground chambers. When the comparisons are made, the differences are sharp. The claims often describe straight passages running far below the plateau. The real quarry cuts do not form straight lines below ground. They remain close to the surface and often widen only near the top. Claims also describe large halls, but the largest quarry cuts are open pits above ground, not enclosed spaces below. This steady understanding has grown stronger as more studies are made. In recent decades, teams have used light scanners to build 3D maps of the quarries. These maps show the surface dips, side walls, and natural cavities with precise detail. Nothing in these maps matches the idea of city-like structures under the plateau. Instead, the maps show a landscape shaped by both nature and the work of thousands of builders who needed stone, not space. Even with all this clear evidence, the idea of underground complexes remains popular in some circles. This happens because the quarries look dramatic in photographs. When seen from certain angles, their shadows can look like entryways. The uneven floors can look like hidden exits. Without context, a small hollow looks large. Without scale, a crack looks deep. But science returns the same answer each time the ground is scanned, measured, and studied. The lower layers of the plateau hold only natural hollows and quarry marks. There are no larger features waiting behind them. The slow work of understanding these quarries has shaped the modern view of the plateau. Each study adds clarity and removes confusion. Each measurement gives a more complete picture of how the ancient workers shaped the land. Their work left strong evidence of their methods, but no evidence of underground settlements or secret complexes. The stone they cut still shows their actions clearly, even after thousands of years. In this way, the story of what lies beneath the pyramids becomes clearer. The stone below is marked by hands that worked with purpose, but their purpose was to build upward, not inward. Everything on the surface points to the same truth. The quarries show the work of people who shaped stone for a great project, not people who carved cities below the earth. The plateau carries their marks, but not the myths. The story settles deeper now, moving from the open ground of the quarries to the shaped spaces inside the Great Pyramid itself. The air grows still in this part of the tale, as if the narrow passages hold their own quiet. Light touches the stone in thin lines, and each surface tells something about how the builders carved through the bedrock and created one of the most studied interior layouts in the world. Nothing here suggests lost rooms or hidden cities. Instead, it shows careful planning and simple methods used. With skill. The first feature reached when moving downward from the pyramid's entrance is the descending passage. It begins high on the north face, set with tight precision. From the outside, it looks like a small opening, only wide enough for one person to enter at a time. Once inside, the angle becomes clear. The passage slopes down at about 26 degrees. The builders cut it straight through the limestone, following a single line with little deviation. The walls are smooth, though not polished, and show where chisels struck the stone in short, steady strokes. As the passage extends downward, the sense of space changes. The ceiling is low, the width narrow, and the floor even. These choices were made so the structure above would not weaken. The builders shaped the passage to remove only as much stone as needed. No trace shows that they carved for storage or living space. Everything points to a purpose linked to the pyramid's internal design, rather than any idea of underground life. The descending passage leads to the subterranean chamber, often called the lowest chamber inside the pyramid. This room sits carved into the natural bedrock beneath the giant structure. The chamber is unfinished in many ways. The ceiling is uneven. The walls have rough surfaces. The floor drops into a small pit near the center. These features show that the builders may have changed their plan during construction, or had decided that deeper work was no longer needed for the final layout. The chamber's unfinished look has often led to speculation. Some early visitors thought work had started on a grand hall that was never completed. Others thought the room hid signs of something older, but studies have shown that the marks match the same type of stoneworking found in other unfinished rooms across Egypt. The workers carved down until the plan changed, and then they stopped. There is no sign that the chamber was meant to hold people or goods. It holds only the marks left by workers who paused their task and moved on to other parts of the building. Inside the descending passage and chamber, there are no tool marks that suggest advanced machines. Each line on the stone matches hand tools made of copper or harder stones used as pounding tools. When examined closely, the marks show a repeated pattern of tapping and scraping. The workers shape the rock slowly, removing thin layers piece by piece. This slow method gave them control over the angle and alignment. It also meant that the walls show a mix of smooth and rough textures, depending on how much finishing was required. Measurements inside the descending passage reveal how exact the builders were. The width stays close to a consistent value. The angle remains steady from start to end. Even the small shifts inside the stone show no major error. Modern equipment confirms this level of accuracy. It is clear that the builders understood how to keep their cuts aligned, even while working in low light with simple tools. Their choice of a downward slope was deliberate. It placed weight from the structure above onto solid rock, not onto hollow space. The materials used inside these areas differ from those higher in the pyramid. While the upper chambers use granite and well-cut limestone blocks, the lower parts rely mainly on the natural bedrock. This difference shows practical planning. Granite was brought in for areas under heavy stress, while the lower portions did not require such materials. The workers used what the ground offered, shaving away only what was necessary. This simplicity helps modern researchers understand how the structure was balanced. Scientific studies have mapped the subterranean chamber with detailed scans. The shape is irregular, but the data shows that it follows the bedrock's natural contours. The chamber does not extend into a wider system beneath the plateau. It is a single space carved with a clear boundary. The pit in the floor also ends at a fixed point. When measured, the pit shows no signs of continuing deeper or branching into other areas. It is a shallow cut, not an entrance to anything larger. Structural analysts have studied how the descending passage interacts with the weight of the pyramid above. Their models show that the passage stays stable because it passes through solid rock for most of its length. The bedrock supports the weight well. The chamber also sits in a safe zone where the stress from the pyramid's mass is balanced. This layout confirms that the builders understood the forces involved. They placed the passage and chamber where the ground could support them without risk. One detail that often leads to wonder is the smoothness of certain sections inside the descending passage. Some surfaces feel almost level, even after thousands of years. This is not due to advanced technology. It comes from simple repetition. Workers scraped the stone with copper tools again and again until the surface reached the needed shape. The narrow width made the work easier to control, and the downward angle allowed debris to slide out as they worked. Over time, these strokes formed straight planes. There is also the matter of alignment. The descending passage points almost exactly to the northern sky. This alignment was intentional, not accidental. The builders used stars to guide the orientation of the entire pyramid. The angle of the passage may have been linked to specific observations the builders made during construction. The alignment helps experts confirm the dating of the structure and supports the understanding that these features were planned with care, not added for secret use. Inside the subterranean chamber, there are a few places where the stone shows deep grooves. Some people once believed these grooves must mark hidden doors or pathways. But when studied under strong light, the grooves show the shape of tool swings. These marks come from workers trying to flatten the surface. Because the chamber was never finished, these marks remain as they were left. They do not point to any deeper area. Instead, they reveal how the room was shaped before work stopped. The chamber also contains scattered fragments of stone that fell from the ceiling as the workers carved. These fragments are small and show how thin slices of rock were removed. They match the mineral makeup of the surrounding stone. Their presence helps prove that the chamber is exactly what it seems. A space carved in progress, not a place built for long-term use. Researchers often note that the subterranean chamber has no carvings or symbols. This lack of decoration shows that the room was not meant for ceremonies or gatherings. Decorated spaces in ancient Egypt usually have clear signs of artistic effort. Here, none of that appears. The plainness reinforces the idea that the chamber was either abandoned as a plan or had only a limited role in the pyramid's early stages. Some theories once claimed that these underground areas were part of a lost network. But modern scanning methods, such as ground-penetrating radar and microgravity readings, show otherwise. These tools detect differences in density below the surface. When used around the Great Pyramid, they reveal no large spaces hiding beyond the known rooms. The bedrock beneath the chamber is solid. The layers follow natural patterns without breaks that would suggest hidden halls. The shape of the descending passage also supports the scientific view. It is too narrow and steep for regular travel. Anyone inside must bend low or crawl. This layout is not suitable for movement of goods or large groups. It also does not connect to multiple rooms. It leads only to the subterranean chamber. These features show that the passage was designed with a small purpose in mind, not a broad one that would require many connected spaces. The builders also used blocking stones higher in the pyramid to control access to certain areas. These stones do not appear in the descending passage. If this passage had been meant to reach a complex network, it would likely have had more security or structural additions. Instead, the simplicity of the design confirms that the lower part of the pyramid served a narrow function. It was a small part of the larger plan, not a gateway to unknown areas. When modern scientists study the chamber and passage, they look for cracks or signs of stress. The findings show that the room is stable. The stone walls hold firm, and only natural weathering affects them. There is no evidence that the builders carved beyond the chamber or started additional passages. The room stands alone. All data supports the idea that this was either an early stage of the pyramid's internal design or a part of the plan that was left unused. Taken together, the features inside the Great Pyramid tell a simple story. The descending passage and subterranean chamber are examples of precise but practical engineering. They show the builders' understanding of rock and weight. They hold no sign of city-like structures or deep networks beneath. Instead, they show how careful planning guided every cut. The workers shaped the rock to match the needs of the structure, leaving behind a trace of their method in every surface. These underground features form an essential part of scientific studies. They help experts understand how the pyramid was built, how plans changed, and how the workers adapted their methods as they shaped the stone. Each measurement adds to this understanding. Each scan gives a clearer view of the space. All evidence leads to the same conclusion. The subterranean features are limited, practical, and connected only to the pyramid itself. This part of the story reveals another layer of truth beneath the myths. The ground under the Great Pyramid holds only the spaces carved by its builders. They made no hidden cities or extended networks. They made only the rooms and passages needed for their design. The stone shows this clearly, and as the story continues, the wider complex above and around these features will come into focus, adding more understanding to the long effort that shaped this ancient site. The Sphinx stands inside a deep enclosure carved straight into the limestone bedrock. When people look at this space today, they often wonder why the walls have such strange marks and uneven lines. The shape of the enclosure seems unusual, and many visitors think it must hide some type of large tunnel system. But the truth is much simpler. The builders cut the floor and sides during the work of shaping the Sphinx's body, removing huge layers of soft rock. They left behind a trench that looks like it could lead somewhere, yet its purpose was only to give workers room to shape the statue. It was never a doorway or an entrance to hidden paths. The rock layers around the Sphinx are not all the same. Some parts are soft and crumble with ease. Other parts are harder and break in clean cuts. When old wind and rain hit these mixed layers, they left patterns that look like curved lines or deep grooves. Some early writers looked at those curves and thought they were signs of water that had flowed inside a tunnel system. But when geologists studied the walls, they found that the grooves matched natural weather marks, not signs of long tunnels. The shape of the trench is also open to the sky. This means rain and wind could reach the stone from above for thousands of years. The marks we see now are the result of long, slow wear on exposed rock, not secret digging. During the 20th century, teams with new tools began to scan the ground around the Sphinx. They wanted to see if there were any spaces empty under the surface. Their gear could detect gaps in the rock, areas filled with sand, or spots where the ground was weaker than the rest. When the first results came back, some people became excited. They thought the readings meant there were rooms hidden under the pores or behind the statue. But when the areas were checked by digging or closer study, the spaces turned out to be small pockets formed by nature. Some were simple cracks where rainwater had moved down through soft layers. Others were old animal dens, widened by erosion. None were chambers built by ancient workers. Close to the Sphinx's back, early excavators found a narrow cut that looked man-made. This raised new questions because the shape did not match natural erosion. Later studies showed that this cut was left behind by old repair projects. Many groups across different ages patched the Sphinx when wind and sand wore it down. When they cut blocks or added layers of stone, they left small openings or trenches that could confuse modern viewers. A person who does not know this history might think the lines mark the start of a tunnel. But when the blocks are mapped and compared, they line up with restoration work, not with entrances to an underground network. Some early maps also showed small cavities near the Sphinx, but these were not rooms. They were simply spots where the ground had been tested for strength during research in the past. Workers dug short, shallow pits to learn how stable the limestone was before placing equipment. When these pits filled with sand and hardened over time, they became harder to spot. Later, when rediscovered, they looked like small cave mouths, yet each one had clear tool marks and no extension beyond its first meter. They were study pits, not tunnels. In the late 20th century, a team used seismic equipment around the Sphinx enclosure. This type of gear sends small pulses into the ground and measures how they bounce back. It can reveal the size of deeper cracks or pockets of air. The early results suggested there might be a large cavity under the Sphinx's front. But when a complete scan was done, the cavity turned out to be a natural dip in the bedrock produced by uneven layers of stone. The dip created a soft echo that early receivers misread. Once better sensors were used, the supposed chamber vanished from the data. This event taught researchers that the local geology can create many false signals. Another round of study took place in the early 21st century. This time, electrical tests and ground radar were used. These tools can show changes in density under the surface. The readings again found some hollow spots, but none matched the shape of a room. Some were thin gaps inside cracked layers. Others were places where plant roots once grew. The tests also found pockets filled with loose sand. These pockets were formed when sand washed down through small openings and built up in lower areas. When people imagine hidden tunnels, they think of long corridors and straight paths. But the pockets seen here were irregular, small, and followed no clear human pattern. The enclosure walls also reveal clues about ancient work methods. When stonecutters removed rock to shape the Sphinx, they left tool marks that run in steady lines. Over time, weather softened these marks, making them harder to see. Some remain, though, and show where workers shaved off layers of limestone. These marks help prove that much of the enclosure shape is the result of human work, not natural folding. But while the workers cut the walls, they had no reason to build rooms in the rock. Their goal was to free the Sphinx from the bedrock. Creating chambers would only weaken the area and cause collapses, so the idea makes little sense from a building point of view. Some old stories claimed there were doors on the Sphinx. These claims grew when early photos showed dark areas along the sides. But closer study proved these dark spots were shadows. The stone in those areas dips slightly inward, and in low light, the shade looks like an opening. When scanned or measured, the rock is solid. No passage extends inward. Old blocks added during repairs can also cast shadows that look like openings. In the past, some viewers did not know these blocks were newer additions, so they assumed the shadows marked entrances. Later mapping corrected this mistake. One interesting feature is on the Sphinx's back. There is a vertical crack that runs down through several old layers of restoration blocks. This crack is natural. It formed when the upper layers dried and shifted. Over the centuries, people patched it with thin blocks, plaster, and other material. When the crack widened again in later ages, the repairs broke apart, leaving an uneven surface. Some think the crack looks like a shaft, but it does not lead inside the statue. It is simply a surface split in weathered stone. The lower parts of the enclosure floor show points where water once collected. During certain ages, rain was more common in this region. When water pooled, it left traces in the stone. These marks include soft curves, smooth patches, and pockets where clay mixed with sand. The shapes look like the start of dug-out rooms, but they have no straight lines or tool marks. They widen at odd angles and stop without any sign of human intent. This type of wear is normal in open pits cut into soft rock. When ancient workers removed the rock to clear space around the Sphinx, they created an area where water could gather. Over long periods, water shaped some parts of the floor and walls. These zones confuse modern viewers who assume that any hollow space must be made by a human hand. At the north side of the Sphinx enclosure, there are a few carved niches. These niches were used by ancient workers to hold tools, lamps, or ropes. They were not meant to lead anywhere. They are very shallow and stop quickly. The niches show how workers used the space during the carving process, but do not indicate any rooms or tunnels. Later, some of these niches filled with debris. When early explorers removed the debris, the empty spaces looked larger than they really were, again causing excitement and false beliefs. Another point of misunderstanding involves sediment layers near the base. In some ages, large amounts of sand blew into the enclosure and settled against the walls. When the sand was later removed, it left soft lines and small cavities. These cavities formed because the sand pressed against the stone for long periods, slowly grinding away the surface. When removed, the remaining pockets looked like deliberate scoops. Without detailed study, someone could mistake them for entrances. But they lack the signs of a human cut, such as straight chisel lines or right angles. During the early 1900s, when French and Egyptian teams worked around the Sphinx, they documented a small trench near the southern wall. This trench seemed like it could be part of a passage, so it soon drew interest. But the trench was only a working pit made by the cleanup team. They dug it to clear the base of old sand and broken blocks. Once they reached stable rock, they stopped. The trench went nowhere. Yet later viewers, unaware of this history, took photos and suggested the pit was older and connected to a larger system. Later records corrected the claim, showing the trench was modern. One famous claim from the mid-1900s stated that there was a chamber under the Sphinx's front paw. This idea appeared because a researcher saw a thin, straight break in the stone. The break looked like a line that might hide a joint between blocks. But later studies showed that the Sphinx's paws were carved from the bedrock, not from blocks. The break was only a natural seam between two layers of limestone. It did not open into any space. Scans showed dense stone behind the seam, proving it could not be an entrance. There were also claims of a deep hollow behind the Sphinx's tail. This idea came from early tests that showed a strange signal in that area. Once new tests were done, the signal was found to be caused by a patch of loose fill left from an old repair. This fill did not match the density of the surrounding stone, so the test mistook it for a hollow. When cleared and checked by hand, the area was solid underneath the fill. No chamber existed. Even the shape of the Sphinx enclosure itself created confusion. The walls have different heights, and their surfaces show signs of many repairs. The arrangement of newer blocks over old stone can give the illusion of outlines and frames. Some viewers think these outlines are doors or blocked passages, but detailed mapping shows that they match the size and layout of known restoration phases. Builders added patch blocks in rows, creating square shapes that resemble sealed doors. These rows follow surface wear, not any hidden structure. In the 21st century, more advanced scanning was used. This included multi-frequency radar that could track layers deep under the surface. These tests gave a clear picture of the ground. The radar showed that the limestone layers dip gently, then rise again. The spaces between the layers contain some small voids, caused by differences in strength. But none of these voids form rooms. All have irregular shapes. Some look like thin sheets, others like small pockets. A chamber built by people would have clean edges. None were found. These modern tests also revealed how complex the geology is below the enclosure. There are old fractures that run in diagonal paths. Some were formed when the rock dried. Others came from pressure in deep layers. When these fractures cross, they can form larger openings. But even in those cases, the openings are narrow and filled with loose grit. They have no sign of shaping by tools. These natural cracks can fool older equipment that did not have strong resolution. Early readings could easily misread such cracks as larger cavities. Modern tools fixed these mistakes. A small team also used sound mapping inside the Sphinx's body by studying how vibrations moved through the stone. This confirmed that the statue is solid except for known old repairs. There were no hidden rooms inside the head, chest, or paws. The sound waves moved smoothly through the stone, with no sudden shifts that would mark an empty space. This type of test supported what builders during the ancient age already understood. Carving rooms inside such a figure would weaken it and cause collapse. It would make no sense for the builders to create inner rooms. In addition to the enclosure, nearby ground areas were tested. South of the Sphinx, the ground dips slightly, forming a natural basin. When scanned, the basin's soft shape produced echoes that confused some people. But the basin is shallow and changes direction often. It does not lead to anything. Early claims of tunnels heading under the Sphinx came from misreading these echoes. When a full map was made, the basin turned out to be only a shallow depression. The western side of the enclosure has a few large stones that were added as supports long after the Sphinx was first built. These large blocks do not match the statue's stone. They were placed to keep the walls from falling inward. Over time, gaps formed between these added blocks because of ground movement. Some viewers thought these gaps might be the start of hidden openings, but each gap ends quickly. They are only small separations where blocks shifted slightly. They do not lead anywhere. Much of the confusion about the Sphinx comes from how old the repairs are. Some repairs date back thousands of years. Others are from recent centuries. The mix of old and new stone creates a surface that looks uneven. Areas with newer stone look like blocked doorways, simply because the color and texture differ from the original rock. Without careful comparison, anyone could think these areas hide something. But mapping of block placement shows their true purpose: to patch and reinforce, not to close secret paths. Because the Sphinx is so iconic, many stories grew around it. people imagine hidden halls and deep chambers because the figure is mysterious. But when the geology and the repairs are examined together, the picture becomes clear. Everything seen in and around the enclosure fits natural processes and restoration work. No proof points to the large tunnels often claimed in popular tales. Instead, the evidence shows small, natural pockets, cracks and tool marks from repairs. Many modern teams agree on this. The Sphinx stands in a carved pit made to shape the statue, not to hide rooms. The unusual marks on the walls match what we expect from soft limestone that has been exposed for long ages. The pockets found under the ground match natural processes that form cavities in mixed layers. And every patch, groove and niche aligns with known phases of human work to keep the statue standing. As the studies continue, the view becomes even clearer. The Sphinx enclosure and the areas around it contain natural cavities, man-made cuts from carving, and many layers of restoration. But none of these features point to deep tunnels or large underground spaces. The ground around the Sphinx is complex, but it is not a maze. It tells a story of builders shaping a giant figure, nature wearing down soft rock, and many groups trying to protect the statue from decay. With these facts in mind, the idea of a hidden underground world beneath the Sphinx loses force. Science shows a picture that is stable and consistent. A carved enclosure, shaped rock walls, weather marks, and small natural pockets. Nothing more. When new tools became available for studying the ground under the Giza Plateau, many people hoped these devices would solve every mystery at once. The idea of machines that could look underground without digging sounded almost magical. But these tools have limits, and the results they give must be read with care. To understand what they really showed, it helps to look closely at how they work and what the teams on site actually found. Ground-penetrating radar, often called GPR, sends short radio waves into the ground. These waves move through soil and stone, then bounce back when they meet something different. The device reads the time it takes for the waves to return. By studying the patterns, a team can guess the shape of objects below. But GPR does not give a picture like a camera. The results look more like long ribbons of wavy lines. Only trained people can read them, and even then, the results can be unclear when the ground is very complex. The ground at Giza is filled with mixed layers of limestone, sand pockets, cracks, and old cut zones. The radar waves bounce around inside these layers in many ways, which can cause strange patterns that look like cavities even when none exist. Another method used at Giza is electrical resistivity. This technique sends a small current into the ground. The current moves at different speeds depending on the type of material it travels through. Soft sand gives one pattern, solid stone gives another, and a void gives a different pattern again. By reading the changes, researchers can guess what lies below. But like GPR, this method does not draw a picture. It only shows changes in how electricity moves. If the rock is cracked, or if it has mixed layers that hold moisture, the readings can look like hollow spaces when they are not. A third method that gained attention is muon imaging. Muons are tiny particles that fall from the sky all the time. They pass through solid objects, but slow down when the object is very dense. By placing detectors inside or near a structure, researchers can measure how many muons pass through. Fewer muons mean denser material, while more muons indicate a lighter area. This can reveal large voids. The method became famous after it was used to study volcanoes. Later, teams brought it to Egypt to look inside the pyramids. The method works best with heavy stone, so it is very useful in a place like Giza. When these methods were used together in the same spots, they sometimes confirmed each other. But in other places, one method showed a cavity while another did not. In those cases, the most careful reading always came from comparing all results and checking them against known geology. If the cavity was only suggested by one tool and did not match what the stone layers would logically allow, the team had to treat the finding as uncertain. Many early claims of hidden tunnels came from single-tool readings that were not checked against other data. One of the most widely known projects at Giza is the Scan Pyramids mission. This international team used muon detectors, thermal cameras, and radar to look inside the Great Pyramid in a way never done before. They wanted to study the structure, understand how it was built, and learn more about gaps inside the stone. Their goal was scientific. They did not search for treasure or lost rooms from legends. They also made their results public, allowing experts around the world to test the findings. The most famous discovery from Scan Pyramids was a large void high in the Great Pyramid. The void sits above the Grand Gallery and stretches several meters long. The team could not see a shape, but the muon data showed that the space was real. Many people online claimed it was a hidden chamber, but the researchers did not use this term. They simply said they found a void. When builders made large stone roofs inside the pyramid, they often added spaces above to reduce pressure and prevent collapse. The new void may be one of these stress relief spaces. Nothing suggests it is a secret room meant for ritual use or hidden objects. There is no entrance from the inside. No path leads to it. The shape seems rough and matches what we expect from a simple construction gap. Yet because the void is large, it became the target of many wild claims. Another finding from Scan Pyramids came from thermal scans. These scans showed small temperature differences on the pyramid's outer blocks. Some people claimed that the warm and cool spots showed entrances to secret tunnels. But the team explained that temperature differences can come from many things: the block's size, the type of limestone, how the sun hits its surface, and the moisture inside the stone. When the team studied the patterns more deeply, they found nothing that suggested deep passageways in those areas. The temperature shifts matched known weather effects and changes in block material. GPR was also used around the base of the Great Pyramid. Some early scans detected lines that looked like ramps under the surface. These patterns caused excitement among people who believed in a wide network of underground paths. But once the maps were matched with ancient quarry lines, a clearer picture formed. Many of the supposed tunnel readings matched the shape of old quarry cuts and cracks formed by pressure. The ground under the pyramid has been shaped by both human work and natural processes for thousands of years. This creates many straight or curved edges that radar waves may follow. Without careful review, the results can look like planned corridors, even though they are not. Electrical resistivity tests around the Giza Plateau gave similar problems. Some readings suggested large open spaces under certain causeways, but when the areas were checked with core samples and radar, the openings were found to be shallow dips or pockets of loose sand. Sand pockets form easily in this region because of how the wind moves and how old layers break down. When these pockets form under harder layers of limestone, the resistivity readings can look like voids. But they are too small and irregular to be man-made. One well-known case involved an area south of the Great Pyramid, where a resistivity study found a long, low-density zone. People quickly claimed it must be a tunnel leading to a hidden complex. Later tests using GPR and seismic tools showed that the zone was only a shallow trench dug in modern times during restoration work. The trench filled with sand, and the sand changed the readings. When the actual depth was measured, the trench proved to be less than a meter deep. This example shows how a simple modern cut can cause major confusion when only one scanning method is used. Muon tests on other parts of the plateau produced mixed results. Some scans placed inside nearby tombs showed slight void signals. But when cross-checked with GPR, these signals did not match the shape of an open room. Instead, they matched natural cracks or soft zones where the stone density was lower. These cracks can be long, but very thin. They allow more moons to pass through, which makes them look like larger spaces. But when the shape is studied, they do not have the form of chambers. Another survey used GPR near the Sphinx, though the results were not as clear because of the mixed geology in that area. Radar waves had trouble moving through layers with different moisture levels. Because of this, the GPR images showed many blurred shadows. Some viewers thought these shadows were large rooms. But when the data was processed with updated software, most of the shadows disappeared, proving they were only noise from uneven layers. A large radar scan on the western side of the plateau focused on the worker village area. In this case, the radar results were clear and matched known archaeology. The scans showed old house walls, storage rooms, and bread ovens under the sand. These were confirmed through careful digging. The scans did not reveal any large tunnels or secret areas. Instead, they showed the daily world of the workers who helped build the pyramids. This example helps show that radar can work well when the target lies in simple layers of sand and soil. But when the target lies inside rough limestone full of cracks, the radar results become harder to trust. Not all modern surveys found something new. Several ground teams placed instruments near the Great Sphinx to test old claims of chambers under its pores. Both GPR and electrical resistivity found only small, irregular cavities. Many of these matched cracks in the subsurface layers. When compared with geological maps, the cavities lined up with natural features, not with signs of human work. The tests showed no straight-walled chambers, no long paths, and no signs of doors. The results matched what previous studies had shown many times. The Sphinx sits on solid bedrock, with only small natural pockets under it. One of the most repeated myths about radar surveys at Giza is that they revealed a huge city underground. This story became popular because early GPR users did not fully understand how complex the subsurface is. The radar lines looked like walls, corners, and open squares. But the shapes were later shown to match natural layering. Limestone at Giza breaks in large flat sheets. When radar waves hit the edges of these sheets, the signal can create rectangular patterns. With modern processing tools, these false shapes disappear. Yet the early mistaken diagrams continue to circulate, leading people to believe in structures that the ground does not actually contain. Satellites also helped study the plateau. Some images taken from orbit showed straight lines in the sand. People claimed the lines showed hidden foundations or roofed areas. But many of the lines matched water runoff paths, cart tracks from old excavation teams, and the edges of shallow trenches made during mapping campaigns. When scientists combined the satellite images with ground data, the meaning of the lines became clear. None pointed to tunnels. They were all surface markings. Infrared imaging also helped by showing where the ground stayed warm at night. Warm areas sometimes mean buried stone, while cooler areas can mean empty space. These images helped locate lost tomb shafts buried by sand. Several small shafts were found this way near the worker village, but again, none connected to large tunnels. The shafts were small and vertical, matching known burial patterns. One of the most valuable parts of the scanning work was how it helped scientists rule out certain myths. Many stories claimed the plateau contained a giant maze that linked all the pyramids. If this were true, muon detectors would have shown clear signs of long, open corridors inside the Great Pyramid. Radar scans around the base would have revealed straight lines under the ground. Resistivity tests would have shown repeated hollow patterns in a grid. But none of these signals appeared in the data. What the tools showed instead was a mix of natural cracks, small pockets, and ancient working areas. The results were messy, but did not match the idea of a planned network. These tools also helped settle old debates about alleged anomalies. When early teams in the 1900s found strange readings under certain causeways, they thought they found buried chambers. But when muon imaging and radar were used in the same areas, the supposed chambers vanished. The anomalies were simply results of outdated tools that could not handle complex rock layers. The new tools provided clearer data and allowed old mistakes to be corrected. Some groups argued that the tools were not strong enough to see deeper structures, claiming that major halls lay far below scan range. But muons can pass through large amounts of stone, and a very large room would show a strong signal. None appeared. Resistivity can detect deep changes in ground density. The tests showed nothing that looked like a hall or a long path. Radar can only reach certain depths, but when combined with the other tools, the overall picture becomes complete enough to rule out massive spaces. The absence of supporting signals across all methods strongly suggests these spaces do not exist. When all the scanning projects from the last few decades are placed together, a clear pattern appears. The ground under Giza is layered, cracked, and shaped by both natural and human activity. There are pockets in the rock, but they are small and irregular. There are cuts from ancient quarrying, but they are shallow and do not link into bigger systems. There are old shafts for burials, but these are vertical and isolated. There are working trenches from modern times which can confuse tools if not studied carefully. But none of the methods, GPR, resistivity, muon imaging, thermal scans, satellite study, revealed anything like a vast underground world. The new tools did find things worth studying. They helped researchers understand how the pyramids were built. They showed the structure of the Grand Gallery, the shape of stress relief spaces, and the layering of blocks. They helped locate old worker houses. They found lost shafts and allowed teams to map hidden walls without digging. These discoveries are valuable. They expand knowledge of ancient building, labor organization, and daily life. But they do not support stories of massive tunnels or secret cities. The careful work of reading the data also taught researchers something important. Even advanced tools do not replace fieldwork. Scans must be checked by ground truth, meaning real evidence from digging, or from comparing with known geology. When this careful comparison is done, the results become clear and reliable. The plateau becomes less mysterious but more understandable. As the study of Giza continues, new devices will surely appear. But the lessons from past work will stay the same. Tools must be used with care, compared with each other, and read with a steady mind. When this is done, the story of the plateau becomes calm, solid, and grounded in evidence. The machines show what is truly there: stone layers, natural gaps, old cuts, and the marks of thousands of years of human effort. No hidden world waits below the surface, only the slow, steady truth of the land and the builders who worked upon it. The area around the Giza Plateau holds many small tombs, long shafts, storage rooms, and cuts in the bedrock. At first sight, these features can look like parts of a large and planned world below the ground. But when each group of structures is studied in detail, the purpose becomes clear. They are parts of the large cemetery zones that surround the Great Pyramid and other major structures. They form a grid of burial places built for nobles, scribes, and workers who served the royal court. The layout grew from clear rules, and each cluster had a specific role. When these sites are explained with simple facts, the idea of a hidden city fades away. To begin with, the Eastern Cemetery sits near the Great Pyramid. This space holds the mastabas of high officials and members of the royal family from the 4th dynasty. A mastaba is a rectangular tomb with a flat roof and solid walls. It has a deep shaft inside that leads to the burial chamber. Many mastabas in this zone are arranged in straight rows. The rows create neat paths between them. Each mastaba stands close to the others, giving the area a dense look. If a visitor does not know the history, the grid of structures can look like streets of a small town. But the pattern was for order and respect, not daily life. Most shafts in these mastabas were cut into the limestone until a depth where the rock was firm. The builders placed the burial chamber at the bottom. The long, vertical cut gives the false sense of an entrance to a deeper level of rooms. But inside, the burial space is often simple. The chamber holds a sarcophagus, a few goods, and some inscriptions. There are no side rooms or long passages that lead far beneath the ground. Once the burial was complete, the shaft was sealed. The top was covered with stone blocks. It was not meant for more use. In the Western Cemetery, the pattern looks similar, but the people buried there were from different ranks. Many tombs belonged to priests and officials who served in nearby temples. This cemetery is large, and the mastabas stretch across the desert in long rows. As with the Eastern Cemetery, each mastaba contains one or more shafts, but the plan stays simple. The arrangement gives a sense of order, not the feeling of a multi-leveled city. Some shafts are shallow because the rock below the surface changes. Builders adapted based on how the layers behaved. They stopped cutting when they reached layers that were not safe. A few of the burial shafts in the Western Cemetery reach greater depths. When modern visitors look into these deep cuts, the scene can appear dramatic. The shaft can be narrow, dark, and straight. This often leads to the idea that these were entrances to secret places. But archaeologists who record every detail find no long tunnels or room systems beyond the burial chamber. The depth served a single purpose: to reach a safe rock layer and place a secure burial. There are also storage niches within some mastabas. These small recesses in the wall held items used for rituals. Sometimes the niches stored offerings for the deceased. The spaces look like compartments, but they do not lead anywhere else. They are not parts of a larger complex. They formed a simple part of the tomb plan, meant to hold objects and not people. Further south of the main pyramids, there are more shafts linked to later burials. Some were reused in later periods. When later groups returned to older tombs, they cleared out the shafts, made new cuts, or placed new objects. This mix of use over time creates layers of debris and artifacts. When modern surveys find these layers, the combined features can appear like signs of different buildings. But in truth, they reflect reuse rather than an old city under the rock. Clear notes from excavators show each layer belongs to specific times. Around the plateau, there are also boat pits. These long, narrow trenches held full-sized boats or boat pieces. The builders placed them near the pyramids because the boats had a role in royal rituals. Sometimes the pits were covered with large stone beams. When the beams cracked or sank, the pits looked like collapsed buildings or long chambers. But when the pits were opened with care, they revealed boats rather than rooms. The sides of the pits are straight, but they do not lead anywhere else. Next to the boat pits, there are small storage rooms. Some held tools used in the building process. Others held limestone blocks that were kept aside during construction. These rooms were simple. They had low ceilings and little decoration. Over time, sand filled them. Later, people may have thought they were secret chambers, but the shape and the objects inside make it clear that they were workspaces. The plateau also has traces of a large workman village on the south side. This area, often called the workers' village, shows where the crews lived during the time of pyramid construction. The village had small rooms arranged around clear paths. The rooms held pottery, grinders, fish bones, and bread molds. These remains show daily life, but the village was on the surface, not underground. It sat near the plateau, but was not cut deep into the rock. Still, because it is close to the cemeteries, some visitors assume that small storage rooms near the village open into a network below. But the storage cuts were shallow. They held goods for short periods. Archaeologists found bakeries, animal pens, and supply buildings. These structures filled the needs of thousands of workers, but they were made from mud brick, not stone. Mud brick walls weather away faster than stone, so what remains today are the floors and low wall bases. When sand covers parts of the floors, only small gaps are visible. To an untrained viewer, the low walls can look like the tops of an underground system. But when the sand is cleared, the rooms show their true use. Several shafts appear around the edges of the plateau where the rock dips. Some researchers believe these shafts were for waste or for holding tools. Others believe that some were planned as tombs, but left unfinished. These cuts do not lead to long chambers. They stop after a short depth when the builders hit a band of rock that they did not want to cut through. The shape of the shaft may look like the start of a deeper feature, but the work stopped early. The unfinished surfaces show clear marks of this pause. In some cases, geologists studying the plateau found natural joints in the rock near the cemeteries. Ancient workers sometimes widened these natural cracks to form part of a shaft or small room. When a natural crack met a man-made cut, the combined shapes created a strange outline. Modern visitors may imagine hidden paths, but the crack and the cut had no such role. They simply reflect the way the workers used what the ground offered. Another group of features that creates confusion is the storage chambers tied to temple activities. Some temples near the pyramids had small rooms attached to the sides. These rooms were for holding supplies, offerings, or items used in rituals. The rooms were not deep underground. They were built at ground level. As sand built up around them, the floors became lower than the desert surface. Later, visitors saw only the tops of the walls. This sometimes led to the idea that they were entrances to a deeper space. But once cleared, the true height and purpose became clear. Another factor that adds to the confusion is that the plateau was used over many centuries. As time passed, new tombs were cut near old ones. The builders did not always follow the same plans. Some tombs have straight shafts, while others have slanted ones. A few have twin shafts. This variety makes the area look more complex than it is. But each tomb still served a single person or family. Modern archaeologists record every detail around these tombs. They create maps that show how each mastaba relates to the next. When these maps are viewed as a whole, they reveal a clear pattern. Lines of tombs form a grid, with paths running between them. The grid looks dense, but it is not a hiat maze. It is a cemetery with clear rules. The builders followed a standard plan for members of the court, which is why the mastabas align so well. Some people also point to the number of tombs around the plateau and say that the density must mean a city was here. But a large cemetery does not mean a city had grown below the surface. It only shows that many people, over many years, were buried near the pyramids. They wanted to rest close to the king. Being near the king was a sign of honor. This explains why so many tombs were built. There are also false door carvings on many mastaba walls. These carvings look like blocked entrances. Some people imagine that the carvings mark hidden doors to deeper chambers. But the carvings had symbolic meaning. They were places where the spirit of the deceased was believed to move between worlds. The false door surface is solid stone. Behind it, there is no passage. In several mastabas, small niches held statues of the deceased. These statue niches look like small rooms. When the statues were removed, the empty space seemed like a passageway. But the niche does not link to any deeper part of the tomb. It served as a place where family members brought offerings. Many shafts in the cemetery zones were robbed long ago. Robbers cut their own small tunnels to reach burial chambers. These rough tunnels are shallow and aim straight for the chamber. Later explorers who found these tunnels sometimes mistook them for ancient planned features, but they can be identified by their uneven walls and lack of pattern. They were made quickly and without care. Around the workers' village, archaeologists found long lines of meat processing areas. These areas had deep pits used to dispose of waste from animals. The pits are simple but wide. Over time, the pits filled with sand. This makes the area look like it holds deep, man-made structures. But when the pits are excavated, the layers of old waste show their purpose. Some storage rooms near the village held large ceramic jars. The jars stored oil, grain, and water. When the jars broke, the bases stayed in the sand. Later, visitors saw the jar pits and believed they were holes leading to deeper rooms. But when the sand is cleared, the pits show no extension beyond the jar base. Near the western edge of the plateau, some stone quarries were reused as burial spaces. Workers carved small tombs into the old quarry walls. These quarry tombs have odd shapes because they were cut around the natural walls. The rooms can look like they form a system of connected paths, but they do not. Each quarry tomb is separate. The walls were shaped based on the old cut, not on a larger plan. A few archaeologists also note that the plateau holds many small experimental cuts. These were tests made by ancient workers to study the rock. They carved small trenches or short shafts to see how the rock behaved. When the rock was too soft or unstable, they stopped. Over time, the short cuts filled with sand and debris. When cleared, they look like parts of a larger network, but they stop after a short distance. Some areas near the pyramids were used to store extra blocks during construction. Workers dug shallow pits to hold these blocks. After the construction ended, the blocks were removed, but the pits remained. Over centuries, sand and pieces of rock filled the pits. When modern surveys found them, the shapes seemed like collapsed tunnels. But once cleared, they matched storage pits, not passageways. There are also shafts used for reburial. In later periods, when tombs were disturbed, some bodies were moved to new places. These reburial shafts were simple and shallow. They were not planned as complex structures. They served a single purpose: to place remains safely. But their presence adds to the density of the features around the plateau, which makes the area look like a network. The plateau also holds many marker stones. These stones once guided workers and priests. When the marker stones fell over, they created odd lines on the surface. Some thought these lines marked buried walls, but the stones were not part of any underground structure. When seen as a whole, the cemetery zones, storerooms, pits, and shafts form a large and interesting landscape. But they all relate to burial, work, and ritual. None were built to form a hidden city. The dense layout creates a false picture. Visitors see many features close together. They imagine tunnels that connect them. But when archaeologists clear each part, they find no links beyond the planned tomb systems. The shafts cut near the Great Pyramid appear deep and mysterious. They give the sense of unknown spaces far below. But once each shaft is explored, the pattern becomes easy to understand. Each leads to a single burial chamber and stops. There are no long passages that join different mastabas. The chambers were sealed in ancient times. They were not meant for travel. Even in areas where the rock is fractured, the shapes do not form tunnels. The fractures are narrow and irregular. The ancient builders did not try to turn them into rooms. They preferred to cut clean walls. So when a fracture meets a tomb wall, the outline can appear like an opening. But a closer look shows the fracture does not hold space for movement. All these features show that the ground around the plateau was shaped by many hands over many years. But the purpose of the activity was clear: burial, storage, work, and ritual. When people today walk across the plateau and see many entrances and shafts, they may picture a city-like space below the surface. Yet every shaft has a clear start and end. Every room has a simple plan. The complexity lies in the number of features, not in the depth or in hidden links. By studying each zone step by step, archaeologists build a full picture. The area that seems like a puzzle becomes a set of clear pieces. This understanding helps remove the idea of a vast underground city. The plateau is full of history, but not in the form of tunnels that spread below the surface. It is a place of tombs, storerooms, pits, and workspaces. Each part tells a story about the people who built the pyramids and cared for the dead. Hayat El Ghurab is the area south of the Great Pyramid where archaeologists uncovered what is now called the Workers' Village. The discovery of this village has helped researchers understand how the pyramids were built. The site shows that large numbers of people lived, worked, and ate close to the construction areas. Excavations began in the early 20th century, but the most detailed studies happened in the late 20th and early 21st centuries. Teams dug carefully, mapping each wall, pit, and room, and recording the evidence in a way that allows modern researchers to study life there in detail. The village consists of many housing units. These units were small rectangular rooms made from mud brick, sometimes reinforced with stone bases. The mud brick walls have weathered over thousands of years, leaving low walls and floors for study. Each unit housed several workers, possibly families or groups of laborers who shared tasks. The layout of the units is organized in rows, with narrow paths between them. The rows give the impression of a planned settlement. Archaeologists found signs of doorways, small storage areas, and sometimes simple benches or platforms. The rooms were functional, built to provide shelter and basic living needs. In addition to living spaces, the village contained bakeries. These bakeries had ovens carved into the ground or built with mud brick. Large flat stones were used for grinding grain, while storage pits nearby held flour or dough. Archaeologists found remains of bread and tools for baking. The size of the bakeries suggests that they produced food for many workers at the same time. The ovens and pits are arranged in rows, giving a sense of order. Yet, when viewed from above, these rows of ovens, pits, and rooms can resemble corridors or hidden chambers, especially when filled with sand and debris. The layout can easily be misinterpreted as part of a subterranean complex if someone does not know it was a surface village. Workshops were another key feature of the village. Stone cutters, carpenters, and metalworkers had dedicated spaces. These workshops were often shallow pits or rooms with tools and work surfaces. The stone-cutting workshops contained chisels, hammers, and stone debris. Carpenters' areas held wood scraps, adzes, and simple saws. Metalworkers' spaces contained furnaces for smelting and shaping small tools. The workshops were placed near the housing units, but remained slightly separate to manage smoke, dust, and noise. When archaeologists uncovered these rooms, the tools and debris left strong evidence for daily activity. Yet the arrangement of multiple workshops side by side can create the impression of multiple interconnected chambers if one imagines they extend underground. In reality, all of these spaces sit on the surface. The village also contained administrative buildings. These structures were slightly larger than the housing units. Archaeologists found evidence of offices, storage areas for records, and counters where goods could be counted and distributed. Some walls had niches for storing documents, and nearby bins may have held supplies for daily tasks. These buildings helped coordinate the movement of workers, the distribution of food, and the flow of building materials. Their presence shows that the workers' village was a carefully planned operation, organized by the central administration that managed the pyramid construction. The walls and floors of these buildings have survived in fragments, allowing archaeologists to reconstruct the layout. Evidence from the site shows that the workers' village supported a seasonal labor force. Many laborers were not permanent residents. They came from surrounding areas during the periods when construction work was most intense. Archaeologists found that the floors contained remains of food consumed seasonally, such as fish and certain grains. Animal bones suggest that cattle and goats were slaughtered according to a planned schedule. Pottery styles vary slightly in layers of debris, showing multiple groups of workers lived in the village over time. The seasonal rhythm explains why some areas seem crowded, while others were emptied at intervals. This pattern might have contributed to misunderstandings when modern observers imagined a continuous, city-like underground complex. The village was full of people at certain times, empty at others, creating a layered archaeological record. Excavations revealed that the village had areas for communal activities. There were open courtyards where groups gathered for meals or meetings. Some spaces contained evidence of small altars or religious objects. These open areas, combined with rows of rooms, create a pattern that can look like streets and passageways. When the sand partially covers the walls and debris, it is easy to imagine tunnels connecting the rooms. Careful study, however, shows that the arrangement is entirely above ground. Each courtyard and building serves a clear function connected to living, eating, and working. Archaeologists also found storage pits and granaries in the village. These pits were dug into the ground, but not deeply. They held grain, flour, oil, or other foodstuffs. Some pits were lined with mud brick or stones to protect the contents. Over centuries, sand partially filled these pits. When viewed from above, or in early aerial photographs, the pits appeared as small depressions. The clustering of these pits among the housing units may have contributed to myths of a larger underground network. In reality, these pits were simple storage spaces, and they do not connect to other rooms underground. Excavation teams documented the waste areas around the village. Large trash pits contained broken pottery, discarded food, and debris from workshops. These pits were irregularly shaped and often filled quickly. The presence of these pits close to housing and workshop units, combined with erosion, gives the landscape an irregular, uneven appearance. When first uncovered, these features may have suggested tunnels or chambers to observers unfamiliar with the purpose of waste disposal in ancient settlements. Archaeologists also studied the pathways and streets between the housing units. The streets were narrow and often straight, designed to connect workshops, bakeries, and administrative areas. These paths guided movement efficiently, allowing workers to bring materials to construction areas. Sand has partially covered the original surfaces, and erosion has changed the height of some walls. This makes it easy to imagine multi-level structures or hidden corridors connecting the rooms. In truth, the streets served simple practical purposes and stayed on the surface. Analysis of animal remains and food debris shows that the village operated as a complete living space. Workers ate bread, fish, and meat brought in from other areas. They cooked in communal ovens, stored supplies in pits, and prepared tools in workshops. The village supported the daily life of thousands of people who built the Great Pyramid. These remains, while abundant, are entirely consistent with an above-ground settlement. There is no evidence of subterranean housing, no tunnels connecting the rooms, and no hidden chambers. The village's alignment with the pyramid indicates planning. The layout maximized efficiency. Workers lived close to the site, food was easy to distribute, tools were nearby, and waste could be managed without affecting living spaces. Archaeologists noted that the buildings were oriented in ways that made the best use of the terrain. Slopes, rock layers, and drainage were considered. The village shows intelligence in organization, but it does not indicate that an underground city exists. The planning is surface level, functional, and seasonal. Many early visitors to the plateau saw the clustered ruins of the workers' village and mistook it for an underground network. When only the tops of mud brick walls were visible above sand, the settlement appeared like small rooms without clear connection. Observers imagined that these were entrances to tunnels. However, systematic excavation revealed the room's true purpose. Each space has a roof, walls, and floor built at the surface. The features that looked mysterious are simply part of a dense but above-ground settlement. Another aspect that leads to confusion is the combination of different building types. Housing, bakeries, workshops, administrative offices, storage pits, and courtyards are closely packed. This density, combined with sand coverage, gives the impression of interconnected chambers. Modern satellite images can exaggerate this effect, showing lines and rectangles that seem like walls of an underground complex. Ground-level excavation shows that these shapes are surface structures. They were built for work, food preparation, administration, and living, not for secret passageways. Finally, the village demonstrates the scale of human organization in pyramid construction. Thousands of workers needed shelter, food, tools, and coordination. Hayat el-Ghurab provided all these functions in one area. The careful layout allowed people to live and work effectively without creating a confusing network underground. The features of the village, while impressive, are entirely above ground. Each room, shaft, pit, oven, and courtyard contributes to understanding daily life, labor organization, and logistics during the pyramid building period. None of the evidence supports the idea of a subterranean city. Instead, it shows a surface-level settlement designed for efficiency, support, and order. Many stories about hidden cities under the pyramids began in the early 20th century. Explorers, travelers, and journalists told exciting tales of secret chambers and tunnels, often without evidence. Newspapers printed dramatic headlines that promised discoveries far below the surface of Giza. These stories captured the imagination of the public. They suggested that the pyramids were not only tombs, but entrances to whole underground worlds. Some reports even described elaborate cities with streets, markets, and secret passages. The excitement of the claims made people eager to believe them, even though most were based on guesses rather than science. The origin of these ideas often comes from misinterpreting real archaeological features. Visitors saw mastabas, burial shafts, storage pits, and workshop areas. They noted the dense clustering of tombs and rooms, and with imagination connected them into vast networks. Natural fissures in the limestone also added to the mystery. Water erosion created hollows, cracks, and uneven surfaces that looked like tunnels. People unfamiliar with geology and excavation could easily interpret these as man-made cities below the pyramids. The combination of natural formations and human-built structures gave rise to many legends. In the 1920s and 1930s, newspaper reports often exaggerated small discoveries. One story might describe a single deep burial shaft as the entrance to a lost city beneath the pyramid. Another might show a small workshop or storage pit and claim it was part of a hidden chamber system. Reporters rarely consulted experts in Egyptology. The aim was to attract readers with thrilling headlines. Over time, The repetition of these sensational stories built a widespread belief in underground complexes. People assumed that if some tunnels were real, there must be entire cities beneath the pyramids. Authors of speculative literature also played a role. Popular books combined archaeological reports with imaginative interpretations. Some suggested that ancient Egyptians had advanced knowledge or that unknown civilizations built underground cities. The line between fact and fiction was blurred. Readers who did not check sources or archaeological records often took these ideas as truth. The books often included drawings of tunnels and chambers that had no real basis. The images added to the perception that an underground city existed. Scientific evidence, however, tells a different story. Excavations, ground surveys, and remote sensing show that there are no city-like structures below Giza. Mastabas, shafts, storerooms and workshop areas have clear functions. Archaeologists have mapped each tomb, pit and building carefully. Surveys show that natural cracks and erosion create shapes that can be misleading. When examined carefully, these features do not connect into continuous underground cities. Each cut, chamber and hollow has a logical, above-ground purpose. Over time, real discoveries were sometimes distorted. For example, a small subterranean chamber beneath the Great Pyramid attracted attention when it was first explored. Some reports described it as a gateway to a lost city. In reality, the chamber was part of the pyramid's construction plan. Its function was to stabilize the structure and provide space for the burial passage. Yet, repeated retellings exaggerated its significance. This pattern occurred with other discoveries. Small or isolated findings were amplified into mythical narratives. The combination of imagination, incomplete observation, and media exaggeration created the persistent myth of underground cities. Even today, some websites and documentaries show maps of supposed tunnels and chambers that have never been verified. These claims often mix scientific facts with speculation. They may include accurate measurements of burial shafts or real workshops, but then connect them with invented passages and rooms. The mixture of fact and fiction makes the stories seem plausible to people without archaeological training. It is important to distinguish between the verified features and the myths. Verified features include mastabas, burial shafts, storage pits, boat pits, and worker villages. These are above-ground or shallow-cut structures. They have specific, documented purposes. The myths, by contrast, invent long corridors, connected rooms, and entire cities beneath the pyramids. Scientific publications carefully describe measurements, excavation methods, and functions. Popularized myths ignore these careful reports. By focusing on evidence, archaeologists can show the difference between what is real and what is imagined. Early exploration reports also contributed to misinterpretation. Explorers in the 19th and early 20th centuries often documented discoveries with incomplete records. Sketches, photographs, or notes sometimes lacked scale or context. Later writers used these records to support underground city claims. The lack of precise documentation allowed imagination to fill the gaps. Modern archaeology has corrected many of these early errors, but the myths remain popular in books, movies, and online content. Pseudo-archaeology often takes one real element and builds an entire story around it. For example, a fissure in the rock might be described as the entrance to a tunnel system. A series of shafts may be shown as connected corridors. A small chamber becomes a palace or market. By repeating these claims, a narrative grows that the scientific record does not support. Each claim needs careful analysis, but casual readers often accept them without verification. Educational materials and museum studies emphasize this distinction. Archaeologists explain that myths about underground cities are based on exaggeration, misinterpretation, and media sensationalism. Real evidence is available in excavation reports, maps, and survey data. Visitors to the Giza Plateau can see the mastabas, burial shafts, storage pits, and worker village. Understanding the purpose of these features helps dispel the myths. The density of features does not imply a city below ground. Each feature has a clear above-ground function. Finally, the persistence of the myths shows how powerful storytelling can be. People are drawn to the idea of secret cities hidden for millennia. Yet careful study reveals the truth. Each feature, from burial shafts to worker huts, has a logical explanation. The Great Pyramid and surrounding structures are remarkable achievements. They do not, however, conceal a vast underground civilization. The myths arose from misreading evidence, exaggerating discoveries, and blending facts with imagination. By returning to careful documentation, measurements, and observations, science clarifies what is real and separates it from what is legendary. Over the last century, many large-scale scientific projects have studied the Giza Plateau and its subsurface features. Archaeologists, geologists, engineers, and other specialists have worked together to record, measure, and analyze every part of the area. The goal of these projects has been to understand the pyramids, the surrounding tombs, and the bedrock below without relying on myths or speculation. By using systematic methods, researchers can separate natural formations from human-made features. Each team contributes knowledge from a different field, creating a complete picture of the plateau and what lies beneath it. One important approach is geology. Geologists study the layers of limestone, sand, and sediment beneath the pyramids. They map the cracks, joints, and natural cavities in the rock. This mapping shows that many of the underground hollows are caused by erosion, water, or natural fractures. Understanding the rock helps archaeologists know where it was safe to dig burial shafts, storage rooms, or chambers. Geology also explains why some features appear deep or tunnel-like. In many cases, natural fissures were widened slightly by workers, creating shapes that could be misread as man-made corridors. Seismology is another tool used in large projects. Seismic waves can reveal differences in density and voids under the surface. Scientists send vibrations into the ground and measure how the waves travel. When the waves slow down, it can indicate a cavity or softer material. Seismology helps identify empty spaces without digging. By combining seismic data with maps of tombs and shafts, researchers can confirm which hollows are real and which are solid rock. This method also helps distinguish small burial chambers from larger natural voids. It provides a safe way to explore the subsurface without causing damage. Archaeology continues to play a central role. Teams carefully record each tomb, shaft, and room, noting its size, shape, and orientation. Excavation reports include detailed drawings and photographs. Archaeologists also study pottery, bones, and tools found in these spaces. The artifacts provide information about use and purpose. They show that even when features are large, they were built for burial, storage, or support, not for hidden cities. Archaeologists combine this work with geological and engineering data to understand the full context. Engineering studies complement these approaches. Engineers analyze how the pyramids and nearby structures interact with the bedrock. They model the weight distribution, the stability of shafts, and the pressure on underground chambers. Their work explains why builders made certain cuts, chose specific rock layers, and left some voids. Structural analysis confirms that chambers like the King's Chamber and the descending passage are carefully designed and isolated. Engineering models also show that these chambers are safe under the weight of the pyramid, but they do not connect to large hidden networks. Large-scale projects use remote sensing and 3D modeling to visualize the plateau. Ground-penetrating radar, electrical resistivity, and muon imaging reveal the shape of cavities and rock layers. These tools allow scientists to create three-dimensional models of the plateau and its subsurface. The models show the mastabas, burial shafts, workshops, boat pits, and small chambers. They also display natural fissures and erosion features. When viewed in 3D, it becomes clear which features are artificial and which are natural. The models help researchers communicate findings clearly to both the scientific community and the public. Verified cavities beneath the plateau are relatively small. The descending passage under the Great Pyramid leads to a subterranean chamber, but it is simple and isolated. Other shafts in the mastabas lead to burial chambers with no additional connecting tunnels. Boat pits and storage rooms, while impressive in number, are shallow and straightforward. Some natural hollows exist in the limestone, but they do not form continuous networks. Large-scale projects confirm that all verified cavities have clear purposes related to construction: burial, storage, or ritual. Measurements of verified structures show their dimensions. Mastaba burial shafts are often several meters deep and narrow. The subterranean chamber of the Great Pyramid has a rectangular layout with planned angles to support the weight above. Storage pits vary in size but remain shallow. Workshops are low and long enough for practical use. Even the deepest natural fissures are irregular and cannot be navigated. The data from these projects provide consistent information. The cavities exist, but they are limited in size, form, and function. They are impressive examples of construction and natural processes, but they are not secret cities. By combining geology, seismology, archaeology, and engineering, large-scale scientific projects create a comprehensive understanding of Giza's subsurface. The plateau's features, both natural and man-made, are now mapped in detail. Researchers can predict where safe shafts could be built, which cavities are natural, and how the site evolved over time. The verified structures demonstrate skillful design and careful planning. They also show how misunderstandings arise when features are viewed without context. Each verified cavity has a purpose, and the evidence confirms that no hidden cities exist beneath the pyramids. After decades of research, a clear picture emerges of what lies beneath the Giza Plateau. Archaeologists, geologists, engineers, and survey teams have carefully documented the pyramids, mastabas, burial shafts, storage pits, and workshops. Ground surveys, remote sensing, and excavation reports show the exact size and shape of each feature. Scientists agree that the known chambers, shafts, and natural cavities are real and measurable. They have specific functions related to construction, burial, and support. There is no evidence for hidden networks or vast underground cities. Each feature, though impressive, fits into a logical plan created by the ancient builders and shaped by the natural landscape. The Great Pyramid itself contains several important chambers. The King's Chamber, Queen's Chamber, and Subterranean Chamber show engineering skill and precise planning. The descending passage leads to the lower chamber, carved into the bedrock. Each chamber has specific measurements, angles, and materials designed to support the massive weight above. Additional shafts within the pyramid served symbolic or practical purposes, allowing airflow or marking ritual pathways. Despite the pyramid's size, these chambers are isolated. They do not connect to other chambers or to imagined networks. The evidence shows careful intention rather than secret underground cities. Outside the pyramids, the plateau contains mastabas and tombs arranged in clear layouts. Burial shafts lead to chambers for bodies and grave goods. Storage pits, boat pits, and work areas cluster around these tombs. The arrangement reflects the social and administrative organization of the builders. Above-ground features such as Hayt el Ghurab, the workers' village, show how people lived and worked. Bakeries, workshops, housing units, and courtyards supported thousands of seasonal laborers. These structures, combined with shallow shafts, explain much of the confusion behind underground city myths. Everything that was built has a practical and logical function. Natural cavities and fissures also play a role in shaping perception. Limestone erosion, water channels, and fractures in the bedrock created hollows and depressions. Some fissures were widened slightly during quarrying or construction. To the untrained eye, these hollows may appear like tunnels or chambers. Scientific studies show that these natural voids do not connect into complex networks. The combination of natural and human-made features contributes to the myths, but careful measurement and mapping reveal their true scale and orientation. Large-scale studies using ground-penetrating radar, electrical resistivity tomography, and muon imaging provide three-dimensional views of the plateau. These studies confirm that the features are mostly shallow or isolated. Surveys match excavation records and show no hidden city-like systems. Verified cavities have clear purposes: burial, storage, support, or ritual function. Even the largest natural hollows are irregular and cannot support human occupation. The comprehensive scientific picture leaves little room for speculation, while providing a detailed understanding of how the ancient Egyptians managed construction and organization. Despite the scientific evidence, the idea of underground cities persists in popular culture. Sensational reports, pseudo-archaeology, and imaginative storytelling reinforce the myth. Dense arrangements of structures, partially buried walls, or fissures in the rock are interpreted as secret corridors or chambers. Early newspapers and modern online content continue to amplify these ideas. Yet, when measured and analyzed, the features always fit the known functions. The persistence of the myth shows how easily imagination can extend beyond verified facts, especially when the site is so mysterious and impressive. Understanding the real features beneath Giza provides a calm and inspiring perspective. The pyramids, mastabas, and worker villages demonstrate extraordinary planning, engineering, and organization. Builders managed thousands of workers, created durable structures, and carved chambers into the bedrock. They integrated their work with the natural landscape, using the rock's strengths while managing erosion and fissures. The combined evidence from archaeology, geology, and engineering highlights human ingenuity and problem-solving, rather than hidden, fantastical cities. In conclusion, the Giza Plateau is a site of extraordinary achievement. Its underground and surface features tell a clear story about construction, burial practices, and settlement organization. Verified chambers and shafts show thoughtful engineering. Natural cavities provide context for erosion and geology. Worker villages illustrate how people lived and supported massive construction projects. All features are understandable through scientific observation, and there is no evidence for secret cities beneath the pyramids. The myths exist in storytelling, but the truth is remarkable in its own right. The plateau is a testament to human skill, planning, and adaptation to the environment, providing a fascinating and fully explained picture of life and construction in ancient Egypt.